Live. Hi everyone, welcome back to Geeks for Geeks practice. In this video today we'll discuss the problem of the day for 25th of December, and the problem name is quick sort on linked list. So please consider giving me a quick +1 in the chat if everyone is able to hear me out, and also like the video if you haven't done that, and then I'll just wait for some time for everyone else to join in and we'll begin with the session for today. This problem, that is quick sort on linked list, has been asked in some companies as well. Let's see the tag. So it has been asked in Paytm, and this is a good problem. It is very similar to the quick sort that you apply on the arrays. The only difference here is that you have to apply the quick sort algorithm on the linked list to sort your given linked list, right? So all of you just quickly consider giving me a +1 in the chat, all those who are present, so that I know that everything is working fine, and within a couple of minutes we'll be good to go with the discussion on this problem. Also, one more thing before moving. So this type of problem can be asked in an interview. The reason for that is because if the interviewer wants to check your knowledge of algorithm, so instead of asking you to implement quick sort on arrays, he might ask you to implement quick sort on the linked list, right? Hi Alok Ranjan Srivastav. So this problem is a medium one and its accuracy is good, that is 66%, and the number of submissions are 10,000 plus, right? So hi Sashi, and all those who have joined, just quickly like the video and give a +1, and I'll just wait for one more minute for everyone else to join in, and then we'll start with this session. So this is very interesting problem. Let me read the problem statement for you. So you have to sort the given linked list using quick sort, and the best time complexity for quick sort is order of n log n. In average case and best cases, and in worst cases it is order of n square, right? Otherwise you might get a TLE. This is the statement. After that it says that in the problem, method 1 takes the head. You have been given head of the linked list, right? And there are multiple test cases given. You have to, every time you have to sort the linked list using the quick sort algorithm. Hi Sujan Kumar Mitra, right? So shall I start with this problem? If everyone is fine, if everything is working fine, I can see it. A lot of people have joined. Please like the video and then we'll start with this problem. Perfect. So let's begin with this problem. Let's say that I have some linked list. Let's say I have a linked list, right? Let's say I have a linked list. It can be anything. Let's say I have a linked list. Let's say if it was something like 1, 9 and 6, right? So if I have this linked list and if I have to sort it, if I have to write this in sorted manner, so it would look like 1, 6 and 9, right? Everyone will agree to that. Like it's just like if I had elements 1, 6 and 9, so if I had to sort them, so they will look like 1, 6 and 9, right? So similarly what you will do here is instead of sorting the array, you have to sort here the linked list, right? So that is the task lies ahead. Apart from this, in this question you have to implement the quick sort algorithm. Quick sort algorithm, right? You have to implement the quick sort algorithm to sort this out. How will you do this? So in the quick sort algorithm, it works on the simple concept, that is divide and conquer, right? It works on the concept divide and conquer. Also it takes a pivot element, and the pivot element does what? The pivot element will help you out in partitioning, right? So the concept is that, let's say you have a pivot element, right? You have a linked list, right? You have this particular linked list. Let's say something like this. Maybe you have something like this. Let's say 20 is connected to 6 is connected to 9 is connected to 7 is connected to 10. So let us say that you choose an element. Let's say that you choose an element 9 as your pivot. Let's say if you choose the element pivot as 9, so in that case what will happen is, if 9 is the pivot, consider that 9 is the pivot, then all the elements lying towards the left of my 9, all the elements that are lying towards the left of 9 will be lesser equal to 9. All the elements lying towards the left of 9 will be lesser equal to 9. It will be 6 and 7, right? And all the elements lying towards the right of 9, that is the pivot element, will be greater than 9. So that means that you will have something like 20 and 10, right? They can be in any other. These can be sorted or unsorted, but the actual situation is that after you apply the quick sort for taking a particular pivot on the particular part of the array that has been given to you, suppose this much linked list is given to you. So what you will do is, let's suppose that you are choosing this as the pivot. So in this case what will happen in quick sort, if this is the pivot, then all the elements towards the left of the pivot will be lesser than equal to the pivot, value of pivot, and all the elements towards the right of the pivot will be greater than pivot. And it is not necessary that this data is not okay, it is not sorted. It can be sorted or not sorted. You can assume that it is not sorted, right? So what you will do after that, you will choose this much part and you will sort it. You will choose this much part, and in this much part you will take a pivot element and then you will be sorting it, right? So this is how it works. Is this much problem statement clear to everyone? Please quickly give me a +1 in the chat if this much part is clear to everyone. Then I'll start ahead with this problem statement. Like I'll start ahead with the explanation, like how we will be taking the pivot and how things will be working, how the divide and conquer algorithm would actually be working. Shall I begin with that? You can just let me know in the comments. Also, please like the video if you haven't done that. Okay. Right, let's begin. Perfect. Hi Abhinav. Right, so what happens is, let's say if you have a linked list, if you have been given a linked list, let's say I'm taking a linked list that is, let's say 20 is connected to 6 is connected to 9 is connected to 7 is connected to 10, right? Hi Aditya and hi Sumant. Right, so if this is the linked list that I am having, so in this linked list, let's say I choose the pivot element. Let's say I choose, hi Shriya, if I choose the pivot element, right, in this I can choose any element as pivot. Either if I have to choose pivot element, I can either choose my head as the pivot, that is the starting of the linked list, or I can choose the end of the linked list as the pivot, right? Or I can choose anywhere in between, but I have to keep it consistent, right? If I have to choose every time that pivot only, right? If I am choosing head as the pivot, so every time whatever part of the linked list I am traversing, that all those parts should be head, the pivot should be head. So let's suppose that I am choosing the pivot as 10, right? Let's suppose that I am choosing the pivot as 10. So in that case, what will happen? Now I have these two. Now I will start the traversal from the beginning, right? I will start the traversal from the head. I start traversal. Let me write it somewhere here. Start traversal from head till the tail, right? Till the tail. What will happen? The assumption, the algorithm works on the fact that after you have traversed once using this pivot, so what will happen? All the elements that are lesser equal to pivot element will be lying towards the left, and all the elements that are greater than the pivot element value will be lying towards the right. So what happens? I start with this node and this node. I start with this node, right? And I check with these two nodes. So what do I see? I see there will be one previous and one current node. So I hope that you know that. I'll be showing you the code part for that as well. But what happens is, first of all, I start from the head. I see, okay, this is my first node, so no problem. I see this node and I see this node. So is this node, what happens is, if you are doing taking the pivot as the last element, pivot is the tail here, right? So if I am doing it like this, so I check, is my pivot, is my current element that I am at, is it lesser than the pivot element? No, it's not less than the pivot element, right? So it's not less than the pivot element. Okay, I'll say no problem. Now what I will say is, I move to the next element. The next element is 6. So this is the previous element that I am having, and this is the current element, right? After this, I see that 6 is lesser than 10, and whenever I see such a situation, I will swap what? I will swap my previous with my current. So what happens is, I swap this and this. So now this 20 and 6 I am swapping. So now this 6 comes here and this 20 comes in here, right? This is what happens. Now my previous and current will change, right? Now I'll be where? I'll be at this element. Now I am at this element. And what happens with this element is, I can see that this is my current element, and can I say that 9 is lesser than 10? Yes, 9 is lesser than the previous, 9 is lesser than equal to the pivot element, right? So if it is lesser than equal to the pivot element, so in that case, what will I do? If 9 is less equal to the pivot element, so I'll say that, okay, I'll swap again. I'll swap the previous and the current. So what becomes? This 9 comes here in place of 20, and this 20 comes here, right? Now I come to this. This is my current element, and and once I see this current element, right, I see this as my current element. So can I say that my current element is 7 and 7 is lesser than equal to 10? That is 7 is lesser equal to the pivot element? Yes. So in that case, what will I do? I will swap 20 and 7. So I swap these two elements. What happens is this becomes 7. Let me write it again, right? Okay, so this becomes 7, this becomes 7, and this becomes 20, right? This becomes 7 and this becomes 20. Now notice one thing, that what happens is you have reached the, now your current is pointing to the last, okay, and you have to iterate until you reach the end. Now what happens is once this much part is done, so what you will do is you will swap your current, you will swap your 10 with 20, right? You will swap your pivot with this element, with this 20. So what happens when you swap? Let's see what happens, right? Let's see what happens. So I'm swapping this 10 and 20. So let's see what this linked list would look like. So let me write it here. Now this is getting swapped. So this is 10 and this is 20. Now notice one thing. Can you notice one thing in this part? Can you notice something with respect to the pivot? Just let me know in the comments quite quick. What can you notice in the pivot with respect to the pivot? Is there any property that you can see with respect to the pivot? Right? Can you observe something? Can you observe something? Right, so with this you can observe something, that notice that this was my pivot element, right? All the elements that are lying towards the left of my pivot, are 6, 9 and 7, right? So all these elements, they are not sorted, but all these elements are lesser than equal to the pivot element, right? All the left is not sorted, elements towards the left of the pivot are lesser than equal to the pivot element, and elements towards the right are greater than the pivot element. Smaller element on the left of the pivot and greater towards the right. Yeah, right. This is what I'm trying to explain. So this is how it works. Now the question is, that is perfect, but how does it give me a sorted linked list, right? So as I said, that this algorithm works on the fact that you are using the concept of divide and conquer, right? So now you know that this much part of the linked list is not sorted, right? Pivot, I don't know about other elements, but pivot is at its correct position. This is correct point made by Shreya, right? Now what happens is, now you see, look at this element, right? You have a left and you have the right. You know that pivot is at its position. So now you will call the same function for this much part, that is the left part, and in this also you will choose the pivot as 7, right? So let's say you have 6, 9 and 7. You choose 7 as the pivot. You check for 6, you say okay, no problem. You check for this, so you say okay, since 9 is greater than 7, so I'll not swap. So what happens after that is, once you reach the tail, so you swap the pivot and you swap 9 with it. So what happens, this becomes 7 and this becomes 9. So can you see that this got sorted, right? This got sorted, and eventually you can say that ultimately this element got sorted, right? This pivot 7, as I had chosen the end of my linked list, the end element of the current linked list as the pivot, so I have chosen 7. So this, with respect to this element, the elements lying towards its left are sorted, and the elements lying towards its right are also in increasing order, and the elements towards the left are decreasing, right? Lesser than pivot. So I have this 6. If I have only a single element in the linked list, that means that, let's say for this 10, I have only 20 in the linked list towards the right. So I can say, if there is only one element, so that will be the situation where I will be making, that is the head element is equal to the tail element. So in that case, I will say that okay, if I reach one element, then I'll consider it as sorted. So this will be my base condition for the recursion that I am calling, that if I have only one element in the linked list, so in that case I'll say that okay, it is sorted, right? Similarly, if I have this 7 and 9, 7, 6 and 9. So I'll call for its right and I'll say that okay, this linked list also has now this current linked list is having only one element. So that is why what will happen with this current element with this 9 is, it since there is only one element, so it is considered as sorted, and now this 6 will also be considered as sorted. So this much part will be sorted. Then after that I'll combine this with this 10 and 20, right? So in this way you will be doing this. Notice that in this I had taken the pivot as the tail element. You can also take the pivot as the head element, right? You can also take the pivot as any element in between, but whatever you are taking, you should be every time doing the partition based on that pivot only, right? Is this much part clear to everyone? Please quickly consider giving up me a +1 in the chat if this much part is clear to everyone, right? Is this much part clear to everyone, like how it is actually working? If you want, I can take another test case as well, right? Shall I take another test case? Let's say if I take if I'm taking something like 100, then I am taking, let's say, 50, then I may take element like 80. I can take an element, let's say 67. I can take another element, let's say I am taking some element like a 40, right? If I am taking these elements, in this case what will happen? Or let's say instead of this 50, if I am taking an element, let's say 55, in this case what would happen? Okay, it's clear to Sumant, right? So what happens is, let's say I choose my pivot. You can choose any element as the pivot. You can choose 100 or you can choose 55, but I am saying that let's be consistent. Let's try and choose only the end as the pivot. You can also choose the code that I have written it for the head, because I wanted to tell you that it can be done using the head and the tail as well. So I mark my last element as my pivot. So this is my pivot. Yes, head as pivot, right? Head as pivot. You can also choose head as pivot. I have written the code using head as pivot, but here I am teaching you this so that you can try to dry run using the head after this live stream is over, right? So if I choose this as the pivot, right, so that you can understand both perspectives, they taking pivot as the end and the pivot as the head. Most people will do it using pivot as the head, so I have taken it using pivot as the tail in this sample example that I am explaining, right? Now I have this element, I see this 100, I see this 100. Can I say that this is greater than? No. So I see this 50, I see, can I say that this 55, this 50 is lesser than 55? Yes. So in that case I will swap 150, so this becomes 50, this is 100, this is 80, this is 67, and this is 55, right? Now I reach this element. Can I say that 80 is greater than 55? Can I say that? Right? I can definitely say that. So that in that case what would happen? Nothing would change, or I would change. What will happen? What will happen? You can just let me know. Let's say instead of this, instead of taking this, let's say if I had taken something like let's say I've taken 45, right? In that case what would happen? I reach this element, right? If I reach this element, then can I say that 45 is lesser than 55, right? So this will look something like this. I swap the 100 and 45, so this becomes 45, this becomes 100, this is now 67, and this is 55. Now I come to this element. Can I say that this element is greater or lesser? So I can see that this element is greater, right? Can I say that? Yes. So after that I come to this element, I see that there is a 55. I see that there is a 55. So with this 55, what can I say? With this 55, can I say that I have reached the pivot? And one more pointer, that is one pointer is here. What I will do is I will swap these 155. So what happens is, this is 55, this is 45, this is nothing but 55, and this will be 67, and this will be 100. So now you'll be able to observe that this part, all the elements towards the left of the pivot are lesser than it, all the elements towards the right are greater than it, right? This is how you will do it. Let me show you the little bit of code for this. Okay, first of all let me submit and show you that my implementation will be working, right? Okay, so it is working. You can see that the code got accepted. After that, let me show you how I'll be doing this. So what I'll be first of all doing is, I'll be getting this function, that is, I'll be having the function initial function, that is quick sort, right? In this I'll be given the head. What I'll be doing is, I'll be declaring a node head, which will be pointing towards the head. If I have no elements, if I have only one element in the linked list, okay, this is the edge case, that let's say if I have in my linked list, in my given linked list, if I have only one element, only one element, right? If I have only one element, in that case what would happen if I have only, let's say, 10, right? If I have only 10, so in that case it is already sorted, and that means that the current next, the head dot next, that is the head next, will be null, right? It will be null if I have only one element, or it might happen that I have no element. So if the linked list is null itself, so in that case I'll say that okay, it is already sorted and I don't need to do anything. If that is not the case, now the question comes that what if that is not the case, right? What if that is not the case? So if that is not the case, so in this case we need to consider new things, right? What do we need to consider? So if that is not the case, so I'll call a recursive function that is getTail, in which I'll be getting the tail, and I'll be calling a function that is solve sort head comma tail. What will this get tail give me? So let me show you here. So this get tail will give me the tail of the current linked list, right? So I am currently at the head, and I'm saying that if my current is not equal to null and my current next is not equal to null, so I mark my current next is equal to current is equal to current next, and I simply return the tail. So in this I am getting the tail because I want the tail of the current linked list that I am having. Notice that I will not be considering the complete linked list since I am doing the divide and conquer, so that is why every time it will be reduced, right? So I call this function for solve head and tail, so that is the head of the linked list and tail of the linked list. So once I do that, so I check if my head is null or my tail is null, or if my head is equal to tail. So if there is no element, if the head is null, if tail is null, that means if there is no element, or if the head is equal to tail, if my head is equal to tail, then there is only one element, so I'll say that it is already sorted, so I'll return. Otherwise, if that is not the case, so I'll choose a pivot, and pivot will be chosen according to a function that is partition. In with this I'll be passing my head and the tail. Let me show you the pivot function. In this I have taken the pivot as the head because I had shown you in the example that you can take the pivot as the end element as well, but here I am showing you another approach, that is taking the pivot as the head. You can also try this out in the test cases that I have given, right? So I mark my pivot as the head, and I mark the current node as the head next and the previous as the head, right? And I iterate. If my current is not equal to tail next, then until that time I keep on iterating. And if my pivot element, if my pivot data is greater than the current data, right? If my pivot data is greater, if the data that I am having in the pivot, if it's greater than the current data that I am having, as I showed you in that part, so I'll be swapping, right? I'll be swapping my previous data with the current data. This is what I had told you in the sample example as well. You can check that out as well, right? Also, you can like the video if you are liking the explanation. After that, I'll update my previous element, and I'll also keep on updating my current element, right? Current is equal to current next. After that, once I'm done with that much part, so I'll simply swap in the end the previous element that I had, the previous element data and the pivot data, right? And in this way what will happen, pivot will get to its position. After swapping this, the pivot element will get to its position, right? And I will return the previous element. What does my previous element denote? My previous element denotes the position of the new pivot, right? I have told you this. Now what will happen once you come out of this partition function? So this partition function gives me the pivot, so that means it gives me the point, the new pivot. So that means I have to call this function again, solve sort, in which I'll be passing the head, and now I'll be passing the pivot, that is the new pivot, and similarly I'll be passing pivot dot next and the tail, right? This is what I'll be doing, and this will be recursively solving. And when will my function return? When I have only one element or I have no element, that is my head is or tail is null, or my I have head is equal to tail, so in which case I am having only single element, right? So in those cases I'll return. So this is how recursively it will be sorting. And I have taken the head here. You can also take the tail, like it doesn't really matter what you are taking. Is this much part clear to everyone? I hope that it is clear to everyone. Just quickly comment down below if this much part is clear to you or not. You can just consider giving me a +1 in the chat so that I know that this much part is clear to all of you. Is it? Please give me a +1 in the chat if the logic part is clear to all of you, and how we are doing the partition and how actually quicksort is working, how to get the tail. First of all, you want to get the tail of the linked list, and for that you need a function, because you don't want your head to go to the tail. Instead you want another variable to be going to the tail, and after that you call a partition function. Partition functions does what? It returns the after you call the partition functions. So in that basically the pivot element is there. Pivot, all the elements towards the left of the pivot element will be lesser than equal to the pivot, and all the elements towards the right will be greater than the pivot. And apart from this, you will return the new pivot position, that will be the previous pointer, right? And after that you just mark your current as the head next and the previous element as the head, as I had told you, and you iterate until you reach the end, that is the tail, right? And if your pivot element is greater than the pivot data is greater than the current data, then as I said, you need to swap the previous data and the current data, right? And you simply keep on updating your previous, and you can also keep on updating your current, right? After that, once you are done with that, so you swap the pivot data with the previous data so that the pivot is at its position, the pivot element will be at its position, all the elements towards the left of the pivot will be at their position, all the elements lying towards the right of the pivot will be at their position, right? All those who have given a +1, please consider liking the video as well if you have liked the explanation part. For this problem, I have tried to put in a lot of effort with all of you, right? After that, what I do, if my head is equal to null and my tail is also equal to null, so in this solve function, so that means if I have only one element, so I'll return, because that part will be sorted. Otherwise, I'll be getting the pivot from this function, and I'll call recursively for head comma pivot and pivot dot next comma head comma tail, right? So for the left part of the pivot, for the left part of the current pivot, that is the part, the pivot is sorted. Now for the left part of the pivot and the right part of the pivot, I am recursively calling this function, and in this way recursively it will be getting solved, right? And since I am doing swapping, so there are no worries, ultimately the linked list will be sorted. So this was the question problem of the day for 25th of December 2021. Thanks a lot everyone for watching, and in case if anyone has any doubt, so they can mention that in the comments. Also one more thing, this question was asked in a company, that is Paytm, right? Question was asked in Paytm. I think that this question might have been asked in other companies as well, but currently this question was asked in Paytm. One more thing, that there is a channel that is Code Era, so I teach there, so you can consider subscribing that channel. Like you can just Google search about that channel and you will get that channel, and in that channel we currently upload lead code weekly contest, we upload weekly and bi-weekly contest editorials. Apart from this, I'm also doing a mastering. If you are into CP, if you are someone who is into CP, so I'm also doing mastering code forces series. In this I have taken 3 topics, that is up till now I have taken sorting series, I have taken the greedy series, I have taken the game theory series as well. Also we are also doing code forces editorials for rounds that are happening. Apart from this, we also do ad coder editorials. So in case if you are into CP, so you can consider checking out the channel. I'll just you can just give me a minute, I'll show you that channel as well on YouTube. So you can just go to this YouTube section and you can search for Code Era and you will get this channel, that is just this channel, and you can check this channel out. Like from after some time, like within minutes, I'll also be doing the daily lead code challenge on this, so you can just consider subscribing this channel. Also you can see that we have various playlists and things like that, like mastering code forces greedy, mastering code forces game theory, and a lot of other things, and you can just check out this channel and consider subscribing this channel. If you we are doing this for community support, so that there is a better programming community, and we are trying to provide the best possible solutions for this. So if in case if you are into DSA or you are into competitive programming, so you can consider checking out this channel, right? And thanks a lot everyone for watching this video. This was it from my side for today, and I'll see you soon in the next one. Make sure to like the video and subscribe the channel.